To study the relationship between frequency N and length L for a given wire under constant tension using a sonometer. Plot a graph between N and 1 by L. Sonometer is an instrument which is used to study the vibrations produced by vibrating strings. It consists of a hollow and rectangular wooden box with a peg A at one end and a frictionless pulley P at the other end.
Madam, how can we find the relationship between frequency N and length L?
When a stretched wire is set in fundamental mode of vibrations, then the frequency of the vibration is given by N is equal to 1 by 2L under root D by M, where L is the length of vibrating wire, that is length of the wire between two bridges, T is the tension in the wire, M is the mass per unit length of the wire when the given wire is stretched under given tension. T, then mass per unit length of the wire M and tension. T are constant. Therefore, from equation 1, N proportional to 1 by L or NL is equal to constant. Hence, if we plot a graph between N and 1 by L, the graph will be a straight line. Let's do an experiment to study the relationship between frequency N and length L for a given wire under constant tension using a sonometer and plot a graph between N and 1 by L. Our aim here is to study the relationship between frequency N and length L for a given wire under constant tension using a sonometer and plot a graph between N and 1 by L. Materials required are a sonometer, a set of 6 tuning forks of different frequencies, hanger with slotted weights, rubber pad, paper rider, meter scale, 2 bridges. Procedure. First of all, place the sonometer on the table so that the hanger does not touch table or floor. Remove wire from the pulley and make sure that pulley is frictionless. If not, then oil the pulley. Replace the wire on the pulley and place 2 to 3 kg weight on the hanger and stretch the wire. Check that there are no kinks in the wire. Place 2 equal-sized bridges under the wire. Make a small V-shaped paper rider and place it inverted on the wire just in the middle of its length between the bridges. Take tuning fork of highest frequency V, hold its stem and strike its prongs gently on the rubber pad and press the pointed end of the stem of vibrating tuning fork on the top face of the sonometer. Starting with the minimum distance, increase the separation between the bridges and repeat step 6 till the situation is achieved when the rider flutters and falls down. Again, place the rider on wire and place the vibrating tuning fork on the top of the sonometer. If rider flutters and falls down again, then measure the length of sonometer wire between the bridges resonating under tuning fork of frequency N. Repeat steps 6 and 7 for 5 more tuning forks of different frequencies with same load and record corresponding resonating length between the bridges. Repeat steps 6, 7 and 8 for each of the above tuning forks with more than the resonating length and then the decreasing length. Find the mean of resonating lengths between the bridges for increasing and decreasing distance corresponding to each frequency. Record all observations in a tabular form. Observations. Value of load and hanger on the wire M is equal to X kilogram. Value of tension on the wire T is equal to mg is equal to X Newton. Table for frequency and resonant length. Frequency of tuning fork N Hertz. Resonant length of the wire L centimeter. Length increasing L1 centimeter. Length decreasing L2 centimeter. Mean L is equal to L1 plus L2 by 2 centimeter. 1 by L centimeter raised to the power minus 1 product NL Hertz centimeter 256 50.1 49.9 50.1 plus 49.9 by 2 is equal to 50 0.02 5.12 288 320 384 480 512. Result: for a given wire under constant tension, the product of resonant length L and the frequency N is constant within the experimental error. This verifies that N is proportional to 1 by L. The graph plotted between N and 1 by L is a straight line which also concludes that N is proportional to 1 by L. This verifies the law of length of transverse vibrations of strings. Precautions: the wire should be free from kinks. The wire should have a uniform area of cross-section throughout its length. The pulley should be frictionless. If not, then oil it. The wire should not be loaded beyond its elastic limit. The paper rider should be always kept in middle of the wire between the bridges. Tuning fork should be vibrated by striking its prong against soft rubber pad. The stem of the tuning fork should be placed gently on the top of the sonometer box. While finding the resonant length, start with a small distance between the bridges. The weight of the hanger should be counted for the calculation of tension in the string. Sources of error: wire may not have uniform area of cross section. Pulley may not be frictionless. Bridges may not be sharp. Weight used may not be standard.
Thank you, ma'am, for this knowledgeable experiment.